Hello everyone, my name is Kunal Ghosh and welcome to my new course on RISC-V instruction set architecture, which is popularly called as ISA. So this is nothing but a language of the computer. This is the way we are going to talk to the computers. So that's the top level description about an ISA. So let us go a bit deep into what this course will be all about. So for example, if you have a C program which you see on my screen, if that C program needs to be run on a computer or on a hardware which has got this particular layout. So basically this layout is nothing but an interior of a chip which is present inside your laptop. So if you want the C program to run on this particular layout, there is certain flow. You need to pass this information to this particular hardware in certain terms. So this is what you do. This particular C program is first compiled in its assembly language program, which is nothing but the RISC-V assembly language program over here. This assembly language program is then converted into the machine language program, which is nothing but the binary language program, which is ones and zeros, which is typically the electronic signals logic 0 and logic 1, which is understood by the hardware of the computer. So this currently it is present in the hexadecimal format. In a real world, it is nothing but it is present in the binary format. So this needs to be converted into a binary format, and finally this bits gets executed in this particular layout, and you get the required output. So for example, in this case, if you want to swap two numbers, through this entire process, the bits gets inside the layout and you get the required output. There is another interface that you need to that needs to be present between the RISC-V architecture and the layout. Is nothing but the hardware description language. So you need to create or implement this particular RISC-V specifications using some RTL. In this case, I have taken an example of Pico RV32 CPU core. So this RTL implements the specifications. RISC-V architecture can be thought of as specifications, and the RTL implements this particular specifications, and then finally from the RTL to layout, it's nothing but a standard PNR or standard RTL to GTS flow. So the entire flow starts from the RISC-V architecture. It starts from an architecture. It is being implemented using an RTL, and from the RTL to layout, this is how it will look like. So at the end, from the user point of view, you just implement this particular, or you just execute this particular swap program, and that should get automatically executed by the chip of your hardware, and you should get the required outputs. So what we'll do is we'll stop at this point, and this is the brief introduction about what this course and what the upcoming course will look like. And let's stop at this point. In the next video, let's get deeper into what we just talk about. So we'll talk about from an application point of view. We'll talk about from application, let's say from the regular day-to-day applications that we use. So we'll talk from this point and we'll reach to the chip level. So let's stop at this point and let's start from this and let's start from the application software from the next video. Thank you.